Eric. Oh, so what? That's a really good way to say that. A parallelogram with vertical lines and horizontal lines congruent. That's really good. I never thought of that. Definitely that word parallelogram is important to say, because if you say it's a parallelogram, all the things about parallelograms are true, right? That you know opposite sides are congruent. Opposite sides are parallel. What else do we know? Opposite angles are congruent. All that stuff. Anybody else think of an extra word you might, that, like, I love it, by saying vertical and horizontal. Anybody else think of a rectangle another way? Like, just thinking of vertical lines and horizontal lines? Thinking about angles? I like that. But, this is your book definition. Fits that stuff. He said, this says a parallelogram with 4 right angles. If you say with vertical lines and horizontal lines congruent, does that give you right angles as well? Yeah, and so your definition also works. You don't have to write all this stuff again, but I put a lot of extra stuff here of everything we know about a parallelogram applies to this. So, we know that opposite sides are parallel and congruent. That word parallelogram tells you that. So if you use the word parallelogram, you don't say that. What else is true of parallelogram? Opposite angles are congruent. Again, we know that because of a parallelogram. Consecutive angles are supplementary. We know that because it's a parallelogram. The diagonals bisect each other. Parallelogram. It tells us all of that. So, what's really great is when you get definitions, if you say it's a parallelogram and you know all the things that are true about a parallelogram, that one word, right? By saying that one word, it replaces all of this. So, you want to make sure you don't just say it's a quadrilateral, because not all quadrilaterals have all this. So and you know about rectangles, so I don't think that we need to spend a lot of time on this, which is why I kind of condensed it. And I started writing this. I don't know. I kind of struggle with the word diagonals, so diagonals. Maybe there's another O in it. I know, well, the notes are the same. Like, these are the notes I printed for you, right? So, but this, right? Diagonals. I don't know. That's what I want. Alright, just so you know, this is going to happen the whole day, so. Probably. I have to fix all these hidden boxes. Actually, I'll just fix it. Okay, thank you, Emma. You think I would have caught that myself? Okay, so because it's a parallelogram, we know that the diagonals bisect each other. A rectangle has a special thing. How do you know it's a rectangle and not just a parallelogram? Well, we know because of the right angles, but also in a rectangle, the diagonals are congruent. I can hold 2 pins in my hand, so I can throw one at you. So if you know this is a rectangle, then we know that JL not only bisects MK, but we know that they're the exact same length. And that's not true on all parallelograms, but it is true on rectangles. So just like we've been doing parallelograms, so I didn't put a ton of examples on this, They're just going to ask you information. If you know it's a rectangle, then you can solve for missing stuff, whether it's in terms of x's or they give you actual sides here. So I gave you a story problem here that says a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK equals 12 feet and LN equals 6.5 feet, find KM. JK is 12. LN is 6.5. Hear it? Is that what we're saying? Not for you. Here, let me redo Garrett's question in case you didn't see. So in a rectangle, if they cross like this, Garrett says, are we saying that this side and this side is the same as this side and this side? What is that? It is what that theorem says in addition to what we already know about parallelograms, right? In parallelograms, if this is just a parallelogram, we know that this side is congruent to this side, and this side is congruent to this side. But because it's a rectangle, we're saying those are the exact same length, and they go through the middle. So you're exactly right, Garrett. We're saying that in a rectangle, those are all equal to each other. That's all you gotta do. So if this is 6.5, that means this is 6.5. That means this is 6.5. That means this is 6.5. So do we even really need that 12? So it was just given us useless information here. So to find Km, it's just 6.5 plus 6.5, which is 13. What relationship do you think it is? What relationship do you think it is?
Well, I wouldn't quite know because it's just.
Yeah, I don't know.
Well, a couple of.
We'll have to look and see. I don't know. Anyone else have a question about that? Is that all I gave you on rectangles? Oh yeah, one more thing. Oh yeah, this just says, just like we said yesterday, how do we prove something's a parallelogram? Well, if it has opposite angles that are congruent, then it's parallelogram, or those kind of things. So this is just kind of the thing that goes with the last theorem. It says if you have a parallelogram and you know the diagonals are congruent, then you know it's a rectangle. So if you didn't know those were right angles, but you knew that these were all congruent, then that's enough information to determine that something's a rectangle, just like we did the rules yesterday. So this says Max is building a swimming pool in his backyard. He measures the length and the width of the pool so that the opposite sides are parallel. He also measures the diagonals of the pool to make sure that they are congruent. How does he know that the measure of each corner is 90 degrees? Yes. Exactly. So, write all that. Do you see where this might be useful in real life and when people are building things? If you didn't have a way to measure the angle, but if you wanted to measure the seam in on the 90 degrees, if you measured out parallel lines and then you measured out the diagonals and they were equal, then that verifies that that's a 90 degree angle without. So yeah, that's exactly right. So let's shorten this. Opposite sides parallel means parallelogram. And if diagonals, let's come down here. If diagonals are congruent, then it is a rectangle 90 degrees. Really, I should say it's a rectangle and a rectangle at 90 degrees. I can't really say. Why should I even give you homework in this, right? I didn't want to do this by itself because I didn't think there was a need for me to give you homework just over rectangles. But when we put it together with the next section, which is a rhombus and a square, and if you have more than one rhombus, you don't say rhombuses, you say rhombi. So a rhombus and a square. So who wants to give me the definition of one of those? Square. I know you got a square. What's a square? How would you define a square to someone in first grade? All four sides are equal and 4 right angles, right? So, and going with Eric's definition before, parallelogram, right? You wouldn't say that to a first grader, but for us, we can say it's a parallelogram with the conditions of 4 congruent sides and 4 right angles. What about a rhombus? Someone wrote somewhere, I don't even know what it was. Oh, maybe a square with slanted sides. That's what something was. Yeah. It's kind of a good definition, but that means it doesn't have 4 right angles. Okay? I think you can just say a parallelogram with 4 congruent sides. Could, if you have a square, is a square a rhombus? Because a square meets the requirements, right? A square has 4 congruent sides, it just also has 4 right angles. So a square is a rhombus, but not all rhombuses are squares, right? I have a little, kind of like a rectangle. Is a square a rectangle? Yes, because to be a rectangle, you just have to be a parallelogram with 4 right angles. It is. But not all rectangles are squares. So you have to think about, does it meet the requirements there? So a square is the most specific one because it's both, basically like it's a rectangle and a rhombus, right? It meets the requirements. So the theorems about the diagonals, how do we tell if it's a rhombus or looking at the diagonal? So for a rhombus, the diagonals meet at a right angle. So that means the diagonals are perpendicular. So that's kind of cool, which means a square is also a rhombus, which means the diagonals of a square also meet at a right angle. So we can say that if triangle ABC is a rhombus, then we know the diagonals AC are perpendicular to the other diagonals AB. And again, remember, a square is also a rhombus, so that's also true for squares. And we can also say that in a rhombus, then the diagonal bisects each angle. So rhombuses, I just said it wrong. Rhombi and squares, so the squares and rhombus, the diagonals bisect each angle. Yes, I do. Yes.
I'm still watching.
What?
Hello, YouTube.
No people.
How's life?
And so maybe up here, I'm going to put here, a square. Just to remind you. If they give you a square, these things are. So look at this question. It says, and again, I'm kind of not giving you a ton of examples because it's very similar to the examples we've been doing all week, just now with rectangle, squares, and rhombi. But it says the diagonals of a rhombus WXYZ intersect at V if the measure of angle WZX equals 39.5. Find the measure of angle ZYX. And remember, you just have to find that middle angle there. So they give you 3 letters so you know which side you're on. So WZX. X, so that would be here. 39 degrees. Find the angle of ZYX. this whole thing, right? Right, so you have to think about WZX, WZ to X is only right there, but BYX is that entire angle. You need to find both sides of that. True? We could definitely find Z. If this is 30 what do we know about this side? The other thing about diagonals up there. Which means this is 90 degrees, which means all of these are 90 degrees. Oh my goodness. So this is kind of like a 4-step problem kind of, but it's all about just looking at the picture. So you use the two theorems that it bisects it, and that it makes a right angle here. And then you got to go back to last semester and remember that this adds up to 180 degrees, so we can find this side by subtracting from 180. Is it? No, I subtracted 30. 50 and a half, I think. And then what do I know about this side? Right? Or you could just double 50 and a half. So 101. That one didn't take a whole lot of work. They could also give you them with x's, right? And maybe you do have to write an equation and solve it. But if you know that, you're able to solve that question. Okay, the next thing is kind of what we talked about. There's a rectangle, but the rectangle's not a square. And I thought this was a really good visual of if we have this whole group of parallelograms, then anything that's a parallelogram fits in that category. So rectangles are parallelograms, squares are parallelograms, rhombi are parallelograms, and then just these parallelograms that aren't these special ones are also parallelograms. And, yes? What? You said so?
Not bad.
And so then it just shows how you have rectangles, and a square fits into the category of rectangles. You have rhombi, and a square also fits in there. And so that square, a square is a parallelogram, it's a rectangle, it's a rhombus, and it also fits the category of a square. So you could actually name a square all four of those things. But most specifically, you would call it a square. So I don't know if that's helpful or not, but I thought it was kind of a good picture. And so I got a couple more theorems, and then one more thing about coordinate plane, and I'm done. I don't think I made you right at this point. Again, just how do you prove that something's wrong with a square? Well, you can use the definition by showing that all sides are congruent, or squares, so that it's both a rectangle and a rhombus. But if you know the diagonals intersect at a right angle, then you know it's a rhombus. That's not enough to say it's a square, but it's enough to say that it's a rhombus. If one of the diagonal bisects the opposite angles, then that's enough information. So if they just give you one, if you know angle 1 and angle 2, if that's bisected, then that's enough to tell that it's a rhombus. So again, although there's lots of theorems here, like they go directly with the other theorems that we learned. This one's kind of a cool one. If one pair, if two sides right next to each other, so consecutive sides are congruent, so if these two sides are congruent and you don't know anything else about it, that's enough to say that it's a rhombus. Because if these two sides are congruent, we could prove that really easy. What do we know about opposite sides in a parallelogram? They're congruent. So we know this side's congruent to this side, and we know this side's congruent to this side. If you just know that two sides next to each other are congruent, that's enough to say that it's a rhombus. And then theorem 6.20 says if a quadrilateral is both a rectangle and a rhombus, then it's a square, and we kind of know that already as well. So what can we do with this? Now they can give you shapes on the coordinate plane, and they can ask you to classify it with its most specific name or to list all the things it is. Which means if it's a square, you're going to have to show that it has 4 right angles and opposite sides are congruent. Which means we're going to get lots of practice with our slope and our distance. Right, so if you can show it's a square, start there and work backwards maybe, right?
Yeah.
No, right, you don't have to prove it, but it says list, that's what I mean. Like it says, determine whether the parallelogram, is it a rhombus, is it a rectangle, or is it a square? List all that apply. And so you're right, if you find it's a square, then you're also going to say that it's a rectangle and a rhombus. Not that you have to prove that, because you've already, you know what I'm saying? So this is just like what we did yesterday with the parallelograms, only now we're talking about showing perpendicular lines. What do we know about slope and perpendicular lines? Can you prove that 2 lines are perpendicular by using slope? They're reciprocals and one of the perpendicular. Kind of reciprocals. They're opposite reciprocals. So if you want to prove that 2 lines are perpendicular, you need to find their slopes and show that they're opposite reciprocals. So what's the opposite reciprocal of 2? -1/2. And so just like yesterday, I'll give you graph paper because it's much easier to do graphic because you can just count it. But it says determine whether this is a rhombus, a rectangle, or a square. So for me, I always start with the slope because to me it's less work than the distance formula, and I'm going to look for those right angles. If it's not a right angle, which ones can you throw out? It's not a square, not a rectangle, but it doesn't say, well, I don't know, it seems like it's going to be one of them. If we trust, I hope that it's a rhombus. Then we would want to look at the sides like this. Not good. So if I look at the slope of AB, you don't have to show me a ton of work here, but I do want to know what the slope is. And it's really nice if you can just count, right? So I just say up 1, 2, 3, 4 over 1. That's equal 4. It's going to go all the way down here. I guess we want to show, I'm assuming that, oh yeah, I already said it's parallel. If I find the slope of BC, go from B to C, I'm going to go down 1 and over 4. That's good news, right? They're opposite reciprocal, so we've just shown that that's right angle. Do you remember the theorem? Do we have a theorem that says if one angle is a right angle in a parallelogram, what do we know? They all are, because we know opposite sides are congruent. So since they told us already it's a parallelogram, we just saved ourselves a lot of work if you know that rule. So since this is a right angle, I know this is a right angle. Let's see how that turns out. So, and it says explain, which means you need to say that. If you're not going to show me that they're all perpendicular, AB is perpendicular to BC, and if one angle in a parallelogram is 90 degrees, then they all. Right? It's kind of like you're doing a proof. I call these coordinate proofs because you're using the actual numbers in there to find them.
Figured out.
Okay, but it says explain, so you have to show me work, okay? So if we do the distance here, again, do I need to do distance 4 times on this? Because it's a parallelogram, and I know that opposite sides are congruent, right? So I really should only have to do this twice. So I'm going to do the distance of, choose, I'm just going to C, and I'm going to say -1 minus 3 squared plus 3 minus 2 squared. -4 squared is 16 plus 1 squared is the square root of 17. That's a little bit more than 4, right? side, so if this is square root of 17, then I know that this is also the square root of 17, again, because they told me it was a parallelogram. If they didn't tell me it was a parallelogram, then I'd have to do a lot more work. So you just need to pick one of the other sides. So pick CD or BA, it doesn't matter. I'm going to pick CD. I always just write that down next to it so I know what I'm doing here. And I'm going to say 3 minus 2 squared plus 2 minus negative 2 squared. And I think I'm going to get the same answer. So I'm going to get the square root of 1 plus 16, which is the square root of 17. Or you could just say that we have the theorem that says if 2 consecutive sides are the same, then you know it's a rhombus, right? But because it's a rhombus with 4 right angles, is it all of these? It's a rhombus, it's a rectangle, and it's a square? Yeah, it fits all the requirements, because if it's a square, it's also a rhombus and a rectangle. So, through it. So, all that apply, I'm just your homework. So this not only reviews stuff like algebra, coordinate plane stuff, but it also is using all this stuff. I printed your worksheet for homework. Thank you. There's 2 sides today. You don't do them all though, okay? Which is rectangles. Let's do 2 through 12 even. You can just circle some more. 2, 4, 6, and then 7 through 12. Like you can do, like, oh, those kind of all go together, like finding the angles. And then I won't make you do the coordinate sign on just the rectangles, because I want you to do the coordinates when you have to distinguish between rectangles, rhombi, and squares. So that's all you have to do on 6-4 side, is just some algebra at the top and then the angles at the bottom. And then on the 6-5 side, let's just do odds. So 1 through 11 odds. So 1, 3, 5 is just algebra. And look, I have a proof there for you. And then, I know that's what it's so 9 and 11. If you want a graph paper, if you have room on your graph paper from yesterday, you can just use that graph paper. Or if you just want to use that paper. I don't know. So, here's more graphic for you. Do you have like 10 minutes to work on this? I bet you can do this. And we're definitely going to test next week, but don't lose the worksheet from today if you're going to keep tracking this worksheet. Give you a chance so you can see how much it's going. I feel like it's a lot easier than but that's because these are made just for education. No, we're not going to test it, but I will tell you that when they gave us the presentation for this, that they do test on it, and they said, they don't know if I'm not going to tell you why. Because it's not guaranteed that it won't break. done that. So they had it like it's made so that I'm not sure if you spill stuff on it. But it's made so if you spill something on it, that it all goes out of it. No, I would do it. Like, you know what doesn't happen, okay? It's made, and you can't go to the store and buy this exact same thing because this is made for schools. Like, it's made the same kind of stuff that they make them when they go to for the army. Like, the ones that they use in Iraq, that hold up to those kind of conditions, are the ones they use for students to be
They're comparing schools to war.
You know how you treat things. You see your textbook. It's not too bad. Like, compared to the other ones, no, I guess. And then it's touch as well. And so, like, it shows that it's like it's all right. So like you can't write it. And so like this, if you're not you're like, oh, I don't have it on. Color yeah, I mean, you can take a while here, but just like you put your book back in, which is good. You can bring it back in and clean them all up, and you'll get like a nice fresh skin. And everything, like this is not my laptop, as you can see that I don't have like Google, but it's all based on Google Drive. So it doesn't matter what super great, it's not great, it's great. But the great thing is you can go and put it back in. I don't know what it costs you. I don't know what happened. I don't know. But anyway, you go and break and you want to do one, they can give you all your people drive. Well, that's it's supposed to be, I think it's 8 hours that it's starting at 4. So the idea is we want to get you trained just like you supposed to go in at night. Then you go to the side. So it's hard to get trained. What do you mean? Yeah, I don't know. The issue is that there's not many plugins. And either you won't have it or you'll be stuck for a while. I would be because, but the idea, what I love about this is you put the charger in here, and you always have your charger. You have to charge at home, you have to charge at school. You can bring your phone. And yes, but you still have to get your phone out. But the idea is that you always have to, the idea is you charge it at night, and then you don't have to be worried about how to order the guys and get what you need, right? Like, that's right, it's just fine. I'm just it's okay, I said all good things. I have a letter of recommendation due at 5 o'clock tonight, and I'm not closing this out for the Chloe Carter. I feel like that was like I feel like there's well, here's what I told my other class. They sell pens, so my advice to you is they sell 8 pens that have a stylus either at the end of each or the other. I don't like the ones that are like rubber. Like, get one of them to simplify, and you can keep it in the bag. Also, bring your headphones and you can keep it in the bag. Because, it's so ugly. Yeah. I don't know the question to that. It's like, go back to the question and get the address. Can you put stickers on it? Can you put that up? I'm going to guess the answer is no. You can't do it with your address either. Or maybe they make you just buy it. I don't know. Like, I don't know the answer to it. But it's okay. I don't think there was like a black wrap. But then you just have to carry it like this. I mean, I can carry it like that. But you can. I know that. No, because you got a little bit of convert. You put her through there. out in the hallway and you don't have the space, like you don't know it. Like, they don't want you walking in the hallway where they're not in it because you know people are going to be tricked or just like people are going to go. There's nothing else. And they're thinking back down in the hallway or not going to be but like, it's getting improved. And so it's not just a case. I mean, it's not just that, but it's a case. Okay, get off. I'm still recording this whole time.
Now they know about the last.